explain in finding the domain of a function. We hope you understand the topic. Now, let's proceed in finding the range of a function. Same with finding the domain of a function, we are going to find the range of each given function in terms of polynomial, rational expression, and radical expression. This time, you solve the equation x in terms of y. Let's proceed to the example. First, find the range of a given function in polynomials. You have a given f of x is equal to x plus 5. To find the range, change f of x to y. That will be y is equal to x plus 5. Next is add both sides by negative x through addition property of equality. Y negative x to isolate the variable x on one side. So, y minus x is equal to x minus x plus 5. Then, subtract x minus x on the left side of the equation. That will be equal to 0. So, the equation we have now is y minus x is equal to 5. Next is add both sides by negative y through addition property of equality. So, the equation will be y minus x is equal to negative y plus 5. Why do we need to add negative y both sides? Because you need to solve the equation x in terms of y so you can isolate the variable x. Then, subtract y minus y, that will be equal to 0. The equation now is negative x is equal to negative y plus 5. To remove the negative sign on the variable x, you need to multiply both sides by negative 1 through multiplication property of equality. Y negative 1 to make the variable x become positive. So, our resulting equation now will be negative 1 times the quantity of negative x is equal to negative y plus 5 times the quantity of negative 1. Negative 1 multiplied by negative x, that is positive x. Next, on the left side of the equation, distribute negative 1 to negative y plus positive 5. Negative 1 times negative y, that is positive y. And negative 1 times positive 5, that is negative 5. Our equation now is x is equal to y minus 5. If the resulting equation is already in x form or in x in terms of y form, and if that is a polynomial, therefore, the range is the set of all real numbers. In symbol, range is equal to y such that y is an element of all real numbers. Let's have number 2 example. You have a given function which is f of x is equal to negative 2x minus 11. In finding the range, always remember that we are solving x in terms of y. First, change f of x to y. The equation now is y is equal to negative 2x minus 11. Next step is add both sides by 2x through addition property of equality. After that, cancel negative 2x plus 2x on the right side of the equation. That will be 0. The equation now is y plus 2x is equal to negative 11. To solve the equation x in terms of y, add both sides by negative y through addition property of equality, so that we can subtract or cancel y minus y on the left side of the equation. Y minus y is equal to 0. The resulting equation will be 2x is equal to negative y minus 11. To remove the numerical coefficient 2 on the variable x, get the reciprocal of positive 2, which is 1/2. Then, multiply both sides by 1/2 through multiplication property of equality. If you can still remember the rule in multiplying fraction to a whole number, give the whole number a denominator of 1. That is 2x over 1 is equal to negative y over 1 minus 11 over 1. Then, since it's both fraction now, apply direct multiplication, which is numerator times numerator, then denominator times denominator. So, the equation now is 1/2 times the quantity of 2x over 1 is equal to negative y over 1 minus 11 over 1 times the quantity of 1/2. Multiply 1/2 to 2x over 1, which is 2x over 2. Then, on the right side of the equation, distribute 1/2 to negative y over 1 minus 11 over 1. 1/2 multiplied by negative y over 1, that is negative y over 2. 1/2 multiplied by negative 11 over 1, that is negative 11 over 2. The resulting equation now is 2x over 2 is equal to negative y minus 11 over 2. On the left side of the equation, since the numerical coefficient of the numerator and denominator are the same, and it is equal to 1. Therefore, variable x will be the only term left on the left side of the equation. Next, on the right side of the equation, since both of them has the same denominator, we can now write them as one whole fraction. The resulting equation now will be x is equal to negative y minus 11 over 2. The range symbols range is equal to y such that y is an element of all real numbers. Number 3, we have a given example f of x is equal to x squared plus 5. Same with number 1 and number 2. Change f of x to y. So, we have equation y is equal to x squared plus 5. Since we're solving x in terms of y, or so-called x form, add both sides by negative x squared through addition property of equality. Y negative x squared, to isolate variable x to the left side of the equation. Subtract x squared minus x squared on the right side of the equation. Therefore, the resulting equation is y minus x squared is equal to 5. To isolate the variable x on one side, add both sides by negative y through addition property of equality. The resulting equation will be y minus x squared is equal to negative y plus 5. To solve x in terms of y, or so-called x form, subtract or cancel y minus y on the left side of the equation. That will be 0. The resulting equation is negative x squared is equal to negative y plus 5. To remove the negative 1 on the left side of the equation, multiply both sides by negative 1 through multiplication property of equality. So, the equation now is x squared is equal to y minus 5. Next, to remove exponent 2, get the square root of both sides. After that, cancel the radical sign on the left side of the equation and the exponent 2. The equation now is x is equal to square root of y minus 5. The given result is in radical expression. Now, always remember that in finding the range of the quadratic equation, it will always become in radical expression. Therefore, the range of the polynomials in quadratic equation is the set of real numbers that make r of x greater than or equal to 5. In symbols, range is equal to y such that y is greater than or equal to 5. For rational expression, example number 1, f of x is equal to 1 over x. First, change f of x to y. The equation will be y is equal to 1 over x. To isolate the variable x on one side, get the LCD, which is x, then multiply both sides by x over 1. Next, since you're solving x in terms of y or x form, on the left side of the equation, x multiplied by y, that is equal to xy. 1 multiplied by 1, that is equal to 1. On the right side of the equation, x multiplied by 1, that is x. Then 1 multiplied by x, that is equal to x. Simplify, xy over 1 is equal to x over x. So the equation now is xy is equal to 1. Since you are solving x in terms of y, to isolate the variable x on one side, multiply both sides by 1 over y. On the right side of the equation, 1 multiplied by xy, that is equal to xy. Then y multiplied by 1, that is equal to y. On the left side of the equation, 1 multiplied by 1, that is equal to 1. Then y multiplied by 1, that is equal to y. To simplify the equation, on the right side of the equation, cancel y. So the resulting equation now is x is equal to 1 over y. So the given equation now is in x form. Therefore, the range is not equal to 0. In symbols, range is equal to y such that y is not equal to 0. For example number 2, we have a given f of x is equal to 1 over x plus 5. Again, change f of x to y. That is y is equal to 1 over x plus 5. Before we proceed, convert the whole number into a fraction form and put a denominator of 1 to y, that is y over 1, then 5, that is 5 over 1, and get the LCD. The LCD is 1 times x times 1. Therefore, the LCD is x or x over 1. Next, to isolate the variable x on one side, multiply both sides by x over 1. To multiply a fraction, multiply numerator to numerator, then denominator to denominator. So, x over 1 multiplied by y over 1, x multiplied by y, that is xy, then 1 multiplied by 1, that is equal to 1. On the right side of the equation, x over 1 multiplied by 1 over x plus 5 over 1. First, x multiplied by 1, that is x. Then 1 multiplied by x, that is equal to x. Next, x multiplied by 5, that is positive 5x. Then 1 multiplied by 1, that is positive 1. To simplify xy over 1, that is xy, is equal to x over x, that is equal to 1. Then plus 5x over 1, that is plus 5x. To isolate the variable x on one side, add negative 5x on both sides through addition property of equality. That is xy minus 5x is equal to 1 plus 5x minus 5x. Simplify. On the right side of the equation, apply the operation that is equal to 0. So we have xy minus 5x is equal to 1. To solve x in terms of y, factor xy minus 5x. That is x times the quantity of y minus 5 is equal to 1. To solve for x, multiply both sides of the equation by the reciprocal of y minus 5. It will become x times the quantity of y minus 5 over y minus 5 is equal to 1 over y minus 5. To simplify, on the left side of the equation, cancel y minus 5. So the resulting equation now is x is equal to 1 over y minus 5. Since the equation is in x form, the range is the set of real numbers except those values of y that make d of y equal to 0. Therefore, the range is equal to y such that y is not equal to positive 5. Next example, with a given f of x is equal to 1 over x plus 5. First, change f of x to y. That will become y is equal to 1 over x plus 5. Before we proceed, convert the whole number into a fraction form. That will be y over 1 is equal to 1 over x plus 5. And get the LCD. Then, multiply both sides by the LCD of x plus 5 over 1. So, on the left side of the equation, multiply x plus 5 over 1 to y over 1. That will be x multiplied by y, that is xy. Positive 5 multiplied by y, that is positive 5y. Then 1 multiplied by 1, that is positive 1. On the right side of the equation, multiply x plus 5 over 1 to 1 over x plus 5. That will be x multiplied by 1, that is positive x. Positive 5 multiplied by 1, that is positive 5. Then 1 multiplied by x, that is positive x. Then 1 multiplied by positive 5, that is positive 5. Simplify, xy plus 5y over 1, that will become xy plus 5y. On the right side of the equation, x plus 5 over x plus 5, that will be equal to positive 1. To solve x in terms of y, add both sides by negative 5y through addition property of equality. That will become xy plus 5y minus 5y is equal to negative 5y plus 1. Simplify 5y minus 5y, that is equal to 0. So the equation now will become xy is equal to negative 5y plus 1. To solve for x, multiply both sides of the equation by the reciprocal of y. That is 1 over y times xy, that is equal to xy over y. On the right side of the equation, 1 over y times negative 5y plus 1, that will become negative 5y plus 1 over y. To simplify, on the left side of the equation, cancel y, that will become x is equal to negative 5y plus 1 over y. Since the equation is in x form, therefore the range is not equal to 0. In symbols, range is equal to y such that y is not equal to 0. Let's have radical expression. For example, number 1, we have a given f of x is equal to square root of x plus 5. Again, always change f of x to y, that is y is equal to square root of x plus 5. To solve x in terms of y or x form, eliminate the square root sign by multiplying both sides by the power of 2. That will become y squared is equal to x plus 5. To solve for x, add both sides by negative x. That will be y squared minus x is equal to x minus x plus 5. To simplify, on the right side of the equation, x minus x, that is equal to 0. So the resulting equation now is y squared minus x is equal to 5. To find the range, or to isolate the variable x on one side, add both sides by negative y squared through addition property of equality. That will be y squared minus x is equal to negative y squared plus 5. Simplify, on the left side of the equation, y squared minus y squared, that is equal to 0. The equation will become negative x is equal to negative y squared plus 5. To isolate the variable x on one side, multiply both sides by the negative 1. So the resulting equation now is x is equal to y squared minus 5. Therefore, the range is the set of real numbers that make r of y greater than or equal to 0. In symbols, range is equal to y such that y is greater than or equal to 0. Take note, since the range is a polynomial, y can be any real number. However, the defining equation is restricted to values of domain that are greater than or equal to 0. Okay, so let's have example number 2 for radical expression. Given f of x is equal to square root of negative x plus 9. First, change f of x to y, that is y is equal to square root of negative x plus 9. To eliminate the square root sign, multiply both sides by the power of 2. So the equation now is y squared is equal to negative x plus 9. To solve for x in terms of y, add both sides by positive x through addition property of equality. So the equation is y squared plus x is equal to negative x plus 9. Simplify, on the right side of the equation, negative x plus x, that is equal to 0. The equation will become y squared plus x is equal to 9. To solve for x, add both sides by negative y squared through addition property of equality, that is y squared minus y squared plus x is equal to negative y squared plus 9. On the left side of the equation, y squared minus y squared, that is equal to 0. So the equation will become x is equal to negative y squared plus 9. Since the equation is in x form, therefore the range is equal to y such that y is greater than or equal to 0.